My name is Daniel Pickett, and I'll be presenting on my project for Machine Learning and Data Mining 1 on ASL Image Classification. So ASL, or American Sign Language, has a sign for each of the 26 characters in the English alphabet. So the task here is to create various models that will take in one of these images of a sign and predict the character that it represents, shown in these examples, and then compare the different models and see which performs best at this task. So there's 29 total classes for this problem, 26 of which are characters, and then also classes for space, delete, and nothing, which is just no hand visible in the image. And on the right here, some examples from each class. So you can see the images have different lighting conditions. Some are much harder to make out than others. Some use different people's hands. The data set's from Kaggle. It has 87,000 images, and it's completely balanced. So there's 3,000 images from each class. Then looking at the features, so the sizes of the images are also all consistent. So they're all 200 by 200 RGB. But you can see in this example, it's more pixelated. So this is how the images are actually represented. So when I've read in the images, I've downscaled them to 25 by 25, just to reduce the number of parameters when I train the models. And then each image is essentially a three-dimensional array. And then each pixel value I've scaled from 0 to 255 to be in the range 0 to 1. And that's done just by dividing by 255. So the first three models that I've constructed are logistic regression, kind of the baseline model, decision tree, and random forest. These are all scikit-learn models, and they take in a flat inversion of the images. And then I've divided the image data set into three splits of 70% training, 15% validation, and 15% testing. And then I've tuned each of these validation sets to find the best parameters to use. So I've shown the hyperparameters I've tuned here and what the optimal values were. And then for my fourth model, I've constructed a convolutional neural network. This diagram shows the architecture of it. So I have 3 convolution layers, each using 3x3 filters. And the first 2 are followed by 2x2 max pooling layers. So all of these combined reduce the dimensionality to this 6x6x50 and capture the locality of the pixels. And then this is flattened out and passed through a dense layer and then a dropout layer, which removes 20% of the weights and helps the model to generalize better. Now looking at the results, so first logistic regression had training metrics around 57%. I used accuracy, precision, recall, and F1, and then testing around 54. And you can see in the confusion matrix, it was kind of all over the place, but generally did an okay job. And then this bottom is just how many it got correct out of the total 13,000 training examples. And the next decision tree, so training was around 99%, but testing was around 86%. So appearing slightly overfit even with the cross-validation, but still better than logistic regression. And then random forest. So this reduces the variance and has a perfect score on training, but also nearly 98% on each of the testing metrics. And finally, CNN performs slightly better than random forest. So here it's around 0.4% higher in this case. And then the confusion matrices, you can see nearly all the predictions are correct, and there's just kind of a few outliers that the models aren't able to get. So just to summarize the results, the CNN performed the best, but random forest was also very effective, whereas the decision tree was being overfit, and logistic regression was just fairly low accuracy in comparison. And then despite having nearly 98%, there's still some examples where in ASL, I have an image on the right here, you can see K and V. They're just very similar, and downscaling them, I think, makes it hard for the CNN to distinguish between them. So for a final boost in accuracy, I think having higher resolution images, not downscaling them as much, could maybe give a slight boost But again, that would require more resources during training, so overall I'm pretty happy with how the results turned out. And lastly, here are some of the references I've used throughout the project. Thank you.